given that out of one call out of 15 between 2 p.m. and 4 p.m. of a week are busy. And we have to find the probability that exactly 2 calls will be busy out of 6 randomly selected calls. Now, let us take P as the probability that a telephone call is busy. Then Q will be nothing but probability that telephone call is not busy. Let's explain it. Now, P is given as 1 out of 15. 1 call out of 15 are busy. So P will be 1 by 15. So correspondingly Q will be 14 by 15. And we need exactly 2 calls. That means we have to find P of X is equals to 2 out of 6 calls. So the value of N is nothing but 6. So the formula is NCR into X to the power of P, P to the power of X, R into Y to the power of N minus R. That is equals to N. N is nothing but 6 here. C, and we need exactly 2 calls, that is 2. And P is nothing but busy 1 by 15. Raised to the power of R, that is square, into Y. Value of Y is 14 by 15. And this will be 4. If we simplify this, the value will be 0.0505, which is nothing but option
A fluid is confined in a piston cylinder arrangement so that the pressure in the fluid is a linear function of volume P is equal to BV, where P in kilopascal and V in meter cube. If the fluid changes from an initial state of 170 kilopascal 0.03 meter cube to a final state of 400 kilopascal 0.06 meter cube, then find the work transfer involved during the process. So here, coming to the solution, the P is given by a linear function of A plus BV. So here it is a linear function of A plus BV. So now substitute the initial and final conditions of pressure and volume, that is P is equal to A plus BV, so that here P1 is equal to A plus B1, P2 is equal to A plus B2. Here P1 is 170 kilopascal is equal to A plus B into 0.03, and here P2 is 400 kilopascal and A plus B into 0.06. So from these two equations we can have the values A and B, where A is equal to minus 16 and B is equal to 7667. So generally A is the units of A is similar to the P, and units of B is the ratio of volume to pressure. So that here now we will have to find out the work transfer involved during the process. So work transfer in a fluid system is given by W equal to PdV. So here P is A plus BV dV. So now integrate our V1 to V2, so that here AV V1 to V2 and plus BV V1 to V2. Sorry, BV square by 2. This is sorry. Now substitute all the values here. A is minus 60 into V2 minus V1 is 0.06 minus 0.03 and plus B is 7667 into 0.06 square minus 0.03 square by 2. So it gives a value of 8.55 kilojoules. So in the option, the right option is B. B is the right answer. Choose the correct statement among the following for a difference in heat capacities. Here we'll have to find out the correct relation for Cp minus Cv. So these are the 4 statements. Cp minus Cv equal minus T dou V by dou T whole square at constant pressure, and dou P by dou V into dou P by dou V at constant temperature. Like this, there are 4 relations. So in these relations, first 1 and 2 are correct and remaining are wrong. So that in the option, the correct option is A. A is the right answer. A single stage impulse turbine with a diameter of 120 cm runs at 3000 rpm. If the blade speed ratio is 0.42, the inlet velocity of the steam will be. Here the blade speed ratio is nothing but it is the ratio of linear velocity of the blade to the inlet velocity of the steam at the blade entrance. So here the linear velocity of the blade comes from the equation pi d n by 60, where d is the diameter of the turbine and n is the speed of the turbine, that is rpm of the turbine. So here D is 120 centimeters, that is 1.2 meters, and here R is N is 3000 rpm, so which is equal to 16, so which gives a value of 188.5 meter per second. So from the ratio formula, see, the linear velocity of the blade to the inlet velocity of the steam is given by 0.42. So from this equation, inlet velocity of the steam C1 is equal to the linear velocity of the blade divided by 0.42. So 188.5 by 0.42, which gives a value nearly equal to 449 meter per second. So in the option, the right option is C. A heat engine using lake water at 12 degrees centigrade as source and the surrounding atmosphere at 2 degrees centigrade as sink executes 1080 cycles per minute. If the amount of heat drawn per cycle is 57 joules, then output of the engine will be in watts. So here the amount of heat drawn per cycle is given by 57 joules, that is heat supplied to the engine is 57 joules, and the heat engine using the source temperature 12 degrees centigrade and sink temperature 2 degrees centigrade, so that the efficiency of the cycle is equal to 1 minus T2 by T1, which is equal to 1 minus 275 by 285, which gives a value of 0.035. So this is the efficiency of the engine, and we know that the general formula for the efficiency of the engine is net work done or work output by heat supplied to the engine, so that here work output is equal to efficiency into heat supplied to the system, so that is 0.035 into 57. It gives in terms of joules, but we want here in terms of watts, so that here the other information is given on the cycle executes 1080 cycles per minute, so that is 1080 by 60, so it gives in watts, so that here is equal to 36 watts, and in the option the right option is D. D is the right answer. According to Prandtl's mixing length theory, the turbulent kinematic viscosity nu T is expressed in terms of mixing length L and the velocity gradient dou U bar y dou y as. So here in the given equations, the equation nu T is equal to L square into dou U bar y dou y is the right answer, and in the option the correct option is C.